Hello and welcome back to the Programming in C++ Part 2 series. In this video we're going to cover Chapter 15, Recursion Exercises. So before we do begin, go ahead and smash the like button, leave a comment, and make sure you're subscribed to the channel. Alright, so the first exercise is Programming in C++ Part 2, Program Exercise 15-8. Alright, and in this exercise we're going to write a recursive function that returns true if its digits of a positive integer are in increasing order. Otherwise, the function returns false. Also, write a program to test your function. Your program should prompt the user for an integer and should output positive and negative messages in the following format. The digits of x are in increasing order, or the digits of y are in increasing order. And task 1, order of digits. So let's go. Here, let's go ahead and start with our function. We don't need any other include statements. And we'll do bool increasing digit. Digits. And we have one integer called num. And we'll semicolon there. Let's go down. Right, here's our integer num. Then we'll see out. Please enter an integer. It's cn num. Let's go if increasing digits. Digits of and we'll use a variable num, and then we'll say are in increasing order. Else cout, and let's use this again. Are not an increase in order. Alright, let's take a quick break. We'll be right back after this. Alright, welcome back. So let's go ahead and pull that up. And let's go function. We'll type it in short. Increasing digits. Hit num. Integer digit 1, integer digit 2. If num is less than 10, return true. And let's do else. Digit 1 equals num. Here's our percentage 10. Num equals num divided by 10. And digit 2 Alright, so we do our digits, else. Okay, so we'll go, let's do another if here. If digit 1 is less than or equal to digit 2, then return false. And return increasing digits. And semicolon. Alright. So here we go. Show you the code. There's line 1 through 18. Go ahead and pause it if you need more time. Then there's 19. Go ahead and pause it if you need more time, and I'll show you the rest of this function. Alright, roll. And there we go. Alright, slow roll it for you one more time. And let's go ahead and try to run this. Enter an integer. Increase an order. So there we go. And let's calculate it. So yeah, I ran this. I had to reset it because I ran 15-7 on this one for whatever reason. That's why it compiled, but it didn't run, or it didn't calculate. The code was compiled correctly, but not for this assignment. But I did correct that. Alright, so let's see what we got here. Still waiting for it to calculate. And we got our green check mark, and then we have our 100% on this one. So this one's good. So we're going to go ahead and move on to our next one, but we will do that right after this. Programming in C++ Part 2, Programming Exercise 15-9. In this one, we're going to write a recursive function, reverse digits, that takes an integer as a parameter and returns the number with the digits reversed. Write a program to test your function. Your program should take an integer as input and output the reverse integer. Reverse integer input and define the reverse digits function is our task. Alright, so let's go ahead and do this. And all we need to do is add our function here, and let's do void reverse digits. And let's do long num. Let's do another long, this time use the ampersand. And reverse num. And then long ampersand again. And we'll call this one multiply. Multip. And we'll semicolon. Alright, so that's our function. Let's go down here and let's long number. Another long called reverse number. Next variable will be long multiplier. And let's initialize this to 1. And then our bool is negative. Equals false. So, is negative equals false. And let's see out enter an integer. Cin number, cout inline. If number is less than 0, is negative, equal true, and number equals number, or number equals negative number. So there we go. And let's go and reverse digits. Number reverse number multiplier and semicolon. Reverse number reverse number. Let's check up here. Reverse number. There we go. Got that up. Alright, so let's go. If is negative, let's go reverse number. Equal minus reverse number, and then we'll cout number after digits reversed. Equal sign that. And let's take a quick break. We'll be right back after this. Alright, welcome back. And let's go reverse number. And inline. Turn 0. And let's get our function. Let's go it down to 35 here and paste that there. Brackets. Let's say if num is less than 10, rev num equals num. Else reverse digits num divided by 10 rev num multip and semicolon. Okay. Reverse digits num divided by 10 rev num reverse digits. Okay, a little spelling issues going on there. And where's this one at? Reverse digits. it up. And let's move on. Let's go multiplier 10 times multip. And let's go reverse num or rev num equals num percentage 10. Let's go times multip plus revenue. Alright, spacing looks different just to show you that that will still work. And that's all we need. So let's look at the code. Alright, so here's one for 18. And remember, as always, go ahead and pause it if you need to. Go down to the next line. So 19 to 33. On down to the rest of the code. And there you have it. We'll slow roll it one more time, so pause it if you do need to. Alright, so let's go ahead and run this. And let's calculate it. And wait for that to calculate. So if we reverse integers input, that happened, and define a reverse digits function. Yep, it does things. Alright. So Alright, we got test 1 and test 2 green, and we have our 100%. So that was it for programming in C++ part 2, programming exercise 15-9. So we're going to move on to our next one, but we'll do that right after this. Alright, next programming. Next exercise is going to be programming in C++ part 2, programming exercise 15-10. Alright, and let's see, this exercise, we're going to write a recursive function sum digits that takes an integer as a parameter and returns the sum of the digits of the integer. Also write a program to test your function. Your program should prompt the user for an integer and output the results to the console. Define a digit sum digits function and output of sum digits. Alright, so let's go to our main and let's get that started. So let's start with our function. Let's go here to line 5. Let's do void sum digits. So I'm going to add these up. Sum digits. Sum digits. And let's go long. We call it long ampersand sum. Then go long num. So, okay, so now let's get to our main, and let's start with long num, and then long sum. And let's initialize that to 0. And cout, please enter an integer. And there, and cin num. Some digits, and we have sum, comma num. Semicolon. sum of the digits of, and we'll go num is, and let's inline, and I'll return 0 here. Alright, let's get our function. Copy that. Let's go 22, paste that there. And let's do our brackets. And do a long, long digit. Oops. Long digit. And let's say if num is greater than 0, so digit equals num percentage 10. Num equals num divided by 10. Sum equals sum plus digit. Here, let's do another quick if num is greater than 0, again, and let's go sum digits. So add these up, sum, and again, sum digits. That's all we need for that. So show you that real quick. This is line 1 through 18. Please pause it as you need it. And line 19 to 35 to the end. And that's the code. Slow word it one more time. Pause if you need to. Alright, so let's go ahead and run it. Digit 362. Sum of the digits of 362 is, something wrong, let me check it out. Alright, I found a problem here. Let's go to line 17. Under this, we didn't put the variable sum, so it didn't sum it, it just gave us the information. But let's do that now. Make sure you change line 17, add this variable sum here after is, and close it out. Let's go ahead and run it again. 634. Alright, 6 plus 3 is 9, 9 plus 4 is 13, that's correct. And we will calculate it. And I'll show you this again in case you missed it. So here's what it should look like. Line 1 through 18, we've got line 17 at this part here, sum variable, and then there's 19 to the end of the code. Alright, so let's see if we got our 100%, still calculating for us. And still like we got 50 again, output digits, nope, still calculating. There we go, so we got that cleared up. Test 1 and 2, and we got our 100%. Alright, so we'll go on to our next exercise right after this. Alright, we're going into programming in C++ part 2, programming exercise 15-11. In this exercise, we're going to write a recursive function, power that takes a parameter, two integers, x and y, such that x is non-zero and returns x to the yth power. You can use the following recursive definition to calculate x to the yth power. If y is greater than or equal to 0, as you see here, picture. Got it. Also write a program to test your function This program should prompt the user to enter a base number x followed by an exponent y and outputs the results. Task 1, program properly calculates the x to the y power. And task 2, define the power function. Alright, so let's go to our main. And this one will need IO manip for this one, so let's go ahead and copy this part of the include statement. Then bring our function, call it integer power, and our variables are going to be an integer called base and an integer called exponent. And semicolon. Alright, so let's go here. So let's go integer x, integer y, cout fixed, show point, and let's do it on two lines. Cout set precision 2, and let's do 6. Alright, so let's go enter base, and that'll be x, x, cout in line, that's it. So copy this and change it real quick. Then we'll do exponent. And this one is y. Alright. Now let's go and cout x space 2 power and we'll do y and then we'll do equals. Then let's go if y is greater than or equal to 0. Cout power. Let's go x, comma y. And line. Then we'll do else. Cout 1.0 divided by static cast. And this will be a double. And then we'll add stronger. Definitely need that later. But we'll do power. Then we'll do x, comma negative y. And 1, 2, 3. That should be fine. Then let's inline. Oops. Alright, so let's take a quick break. We'll be right back after this. Alright, so let's go ahead and show you the code. Actually, let's go ahead and get this function first. We're not done. Forgot about the function. So let's get that. We'll get rid of that semicolon when we get here. So paste that like that. Open brackets, and we go if exponent is equal to 0, return 1. Else if exponent is equal to 1, return base. And we'll do else. Return base times base with base times power. Base and exponent minus 1. There we go. So let's show this code. Make sure you pause if you need to. So let's see if we got anything. Okay, that's good. All right, let's take another look at the code. We did that, so let's go ahead and run this. Enter base 9, enter exponent 4. 9 to the 4th power is 6561. Let's go ahead and calculate it. For that to turn. Right, so got our green test 1 and test 2 at 100%. That's it for exercise 15, or yeah, chapter 15, exercise 11, 15-11. So we'll go into our next one. All right, next we got programming in C++ part 2, programming exercise 15-2. And in this exercise, given two integers x and y, the following recursive definition determines the greatest common divisor of x and y, written GCD xy, as see the graphic below. Note the definition of percentage is the mode operator. Write a recursive statement. Write a recursive function, GCD, that takes as parameters two integers and returns the greatest common divisor of the numbers. Also write a program to test your function. Test 1, GCD test. Test 2, define the GCD function. Right, so let's go to our main. And let's do our function first. It should be this integer, GCD. And we'll use first and second. First, num, and integer second num. Cout, enter first number. Cin, first num. take a quick break. We'll be right back after this. Alright, welcome back. Let's go ahead and close this out here. Bring our return 0 up. Let's grab our function. Copy this. Minus the semicolon. Let's go. And brackets. Let's go if second equals 0. Return first. And let's go else. Return GCD. Second. First. Percentage. Second. Alright, so there we go. This time, let's go ahead and run it first. I'm going to show why it's calculating. Save some time. First number, let's go 11. Second number, 32. Number 32 equals 1. Alright, so that looks good. Let's calculate that, and meanwhile, we'll show you the code. Here we go. So there's line 1 through 18. As always, go ahead and pause as you need to. And there is 19 is blank, so there's the rest of the code. We'll go it again. Pause it if you need that more time. And once again, it's a slow roll. And let's go ahead and check out our calculated grade, see if it calculated yet. And it did, so we got green on task 1, task 2, and we got our 100%. Alright, so let's move into our next exercise. Now we're on programming in C++ part 2, and we're going to cover programming exercise 15-13. And in program exercise 15-13, we're going to, so the Ackermann's function is defined as follows. You got mn equals, as you can see with the graphics here, is the equations in which m and n are non-negative numbers, or non-negative integers. Write a recursive function to implement Ackermann's function. Also write a program to set your function with the following value pairs. So m we have 0013 and n we have 0112. An example of the program shown below. Ackermann 3 equals 33 be 61, Ackermann 3.4 will be 125. So task 1, program produces correct input or outputs. So let's go to our main, and let's start with our function. And since we're going to use an Ackermann function, it's an integer Ackermann, and integer m. Integer n. Simple enough. Alright, let's get to our main. Let's get this. And let's go with cout Ackermann 0, 0, 0, 0. Let's do inline, 2 ends of Ackermann. Just make sure that's spelled right because we're going to copy the next 3. Let's copy this and paste it for the next 3 lines. This is 0, 1, change this to 0, 1. This to 1, 1. Mr. 32. Alright, now let's go return 0. Up. And then let's go ahead and copy our function while we're here. And let's go down and paste it. Put up our brackets. Let's go if n is greater than or equal to 0 and n is greater than or equal to 0. Let's go brackets again. So if n is equal to 0, return n plus 1. Else if n is equal to 0, return Ackerman. And we'll do m minus 1 and 1. Alright, let's take a quick break. We'll be right back after this. Alright, so next, let's go else. Else return Ackerman n minus 1. Ackerman m and n minus 1. Semicolon. And then let's go to our, let's go outside the brackets. To this if, do else here, else return 0. Alright, so there we go. So once again, let's run it first. If it runs, we'll show you the code while we calculate. Alright, so there we go, 0, 2, 0, 0. Select the top one. Okay, there we go. So let's calculate that. And let's look at our code while we calculate. So alright, so there's line 1 through 18. As always, just pause it if you need more time to comb through it. And that's 19 to the bottom. Same thing, and we'll slow roll it one more time so you can see the whole thing. And there you have it. Let's see what our calculation is showing up for us, and we need to get something. Let's check it out. So, failed input output tests, Ackerman 001. Pass that. So we go look at that, and I'll be right back to you. Let's try it again. So look at line 1 through 18. 3, 2, 3, 2. Pause that if you need to. And then the rest. Alright, so we calculated it again. So we got our 100. And we passed. Small typo. We got to do it. Alright, there's our 100. So once again, there's our code again. Line 1 through 18. And then line the rest of the code. 30. Alright, so that's it for that exercise. Let's go ahead on to our next one. Programming in C++ Part 2. Programming exercise 15-14. Here, write a recursive function to implement the recursive algorithm of exercise 16, reversing the elements of any array between 2 indices. Also write a program to test your function. Your program should prompt the user for the integers in the array as well as the low index and the high index. The instructions from exercise 16 have been included below for your convenience. Suppose that int array is an array of integers and length specifics. The numbers of elements in the int array. Also suppose that low and high are two integers such that 0 is less than or equal to low, less than length, 0 less than or equal to high, less than length, and low is less than high. That is, low and high are two indices and integer array. When a recursive definition that reverses the elements in int array between write a recursive definition that reverses the elements in int array between low and high. So task 1, reversing the elements between indices. So let's go to our main. And let's go. Okay, we need to add our CASSERT include statement. Oops, that's not what we wanted to do. Two functions. First one will be void reverse, and the variables are going to be first one integer list, an array box, then integer length, integer low, and integer high. Okay, and let's go void print. Constant integer list, comma, integer length. Right, so let's bring this down. Let's do one line. And here. And let's get our variables int list. Make this 10, and this will equal empty brackets int length equal 10. Alright, so let's go down here and let's take a quick break. We'll be right back after this. Okay, welcome back. Let's go ahead on with our cout. Please enter 10 integers. And let's go 4. Int I equals 0. I is less than 10. I plus plus. out. Enter the value of low. Let's go flush. CIN. Low. C out. And we're going to copy this, of course. Low. We'll change it to high. Value of high. Reverse list length h low and high. So out list after reversing elements between space and low and high inline. Let's go print list length. Then C out inline. Oops. And return 0. And let's grab our first function. Void reverse. H-E-I-G-H-H. High. So follow that one. Just make sure there's no more misspelled words in there. Good. Let's go down and bring our brackets. And let's go assert. And 0. Less than or equal to low and low is less than length. Let's go more here. Assert. Let's go 0 less than or equal to high and high less than length. So, and then semicolon. Assert. Let's try this over here. Okay. Low. That's what I didn't do. Ampersands. There. There we go. Alright, so let's come down here and let's take a quick break. We'll be right back after this. Alright, so here, let's go if low is less than high, this low equals this high. This high equals tip. Oops, messed it up. Should just type it in. Tip. There we go. Now let's go reverse. List, comma, length, comma, low plus 1. High minus 0, or high minus 2. So we come up there, and let's do our void print function, copy this one from up here. See out this eye and let's go see out and 9. Alright, so we're gonna run that. If it runs, we're gonna make sure you get the code. If not, we'll fix it. Actually, we'll show you what we got already. There's 1 through 18. Pause if you need it. And there's 19 through 34. And then 35 to 51. On down to the end of code. Alright, so we'll do it one more time, so if you didn't get a chance to pause it, you can now. Alright, so we got our 100 and we got our tasks, one completed. Let's see what it run. I didn't run it. Let's see what it does when you run it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. This is for enter the value of Alright, that was goofy. But we did get it right, so that's it. So thank you for joining us. That was it for program exercise 15-14, and that's it for this video. So thanks for joining us. Please smash the like button, leave a comment, and make sure you're subscribed to the channel, and we'll see you on the next one. Thanks again, and have a wonderful day.